didn't know you could do that.
Yeah, you can get into other people's courses through the website. I didn't know that, and then he showed me. I was like, wow.
All right, here we go. Hey. I know you want to talk about your identities, and that's awesome, and you will tomorrow or sometime when I see you again. Maybe we'll do that on our video. Who knows? Anyhow, we're on page 61. And we're going to talk about these double angle identities, which I have written there for you. One quick comment. The first thing we're going to do is actually prove this. This is an identity, and we're going to prove this. Let's take this down so you can see that. But before we actually prove that, I want to comment on the cosine identities. There are different versions of it because the main version is cosine squared minus sine squared. And we could derive that the same way we're going to do this one, but we don't have time to do all of them. But remember, what's cosine squared? 1 minus sine squared. So if you thought of this as 1 minus sine squared, do you see how you get that version on the paper there? There's 1 minus 2 sine squared. And similarly, since sine squared is 1 minus cosine squared, do you see how you get the other one that's 2 cosine squared minus 1? So those are all just versions of this one with the substitutions for the squared functions put in. So it's not a big deal, nothing to get freaked out about. But there'll be times when these other versions may be handier to use. All right, here we go. We're going to prove this. This is one of the identities. So as you are memorizing things, you're memorizing sine 2x equals 2 sine cosine. You're memorizing that. We're going to prove it. We're going to derive it so that you know these things aren't just made up. They actually are like derivable. So we're going to think of sine 2x as sine x plus x. Would you agree with that? And now I'm going to do my sine alpha plus beta identity, which says take sine of the first, cosine of the second, plus cosine of the first, sine of the second. You see? These match, right? So that's 2 sine cosine. Okay, so you just proved it. You could do the same thing with this one. You would think of this as cosine x plus x and use that identity. And the same thing with the tangent. We just don't have time to do all that. Okay, now let's look at the next problem, which is another proof or verification. What do you notice about this? Anything? Does anything strike you when you look at this right here?
It's cosine. It's yeah.
Yeah, it's the difference of squares. So it's cosine squared minus sine squared and cosine squared plus sine squared. Right? Fourth minus fourth. Well, what's this? 1. So all we have left is cosine squared minus sine squared, and I know these are brand new to you, but if you look at your colored sheet, that is cosine 2x. So you did exactly what you set out to do. All right, we're going to do some problems with these. Don't worry. But now we're going to talk about the half angle identities. So these these identities are the double angle, so 2x, 2 times an angle. And then you have these half angle identities. And again, that tangent version appears in different forms, and that's nothing to be confused about. This one is a little bit awkward to use sometimes, but if we, this is the tangent of theta over 2, if we multiply the top and the bottom of this fraction by the conjugate of the bottom, then you would have on top 1 minus cosine squared, and on the bottom 1 minus cosine squared. Does that make sense to you? Well, what's that? 1 minus cosine squared. That's sine squared. So now you have 1 minus cosine quantity squared over sine squared. And what happens when you take the square root of that? You just get 1 minus cosine over sine, which is one of the other versions there. So when these things appear in more than one form, it's just because you've manipulated it. Yeah.
Is the plus and minus through all three of them then?
Yeah.
Okay.
Yeah. Oh, no. Only the radical one. Yeah, only the radical one. The signs work out in the other ones. The SIGNs do. And we're going to see how to use that plus or minus here in a minute, because we're going to do some problems. Bronson, was your hand up?
No, I'm sorry.
All right, so now let's use them. All of these formulas are on your sheet, so you don't need to worry about writing them down. They're all on your sheet. We're going to find the sine of 15. Now, we've already done that using 45 minus 30. But now we're going to do it specifically with the half angle identity. So 15 is half of 30. Would you agree with that? So now I'm going to use my half angle sine formula, and theta, or x, whatever variable I used, is 30. So plus or minus the square root of 1 minus the cosine of 30 over 2. Everybody see what I did? So now I gotta figure out the cosine of 30. Root 3 over 2. You okay with that? So I have the square root of 1 minus root 3 over 2 over 2. Yucky, yucky, yucky. That's a complex fraction, so let's times everything by 2. Well, the square root of the top I can't really do much with. But the square root of 4 is 2. Have you seen radicals inside of radicals before? It's okay. It's okay. You can have them. It's fine. But I have to decide if I want the positive or the negative root. And that goes back to what the original problem was. The original problem is the sine of 15. Is the sine of 15 going to be a positive number or a negative number? It's going to be positive. 15's in quadrant 1, so its sign will be positive. Now, if this had been like, I don't know, 285 or something, then I would be using the negative root.
I don't understand what doing, like, multiplying the 2, like, out of the denominator did. Like, what did it do making it a 4?
I multiplied everything by 2
Yeah, like, why do we have to do that?
to get rid of that fraction.
Oh, okay.
You can't have a fraction inside of a fraction.
Okay.
So the 2 I multiplied by was that one right there.
Alright.
Okay, that was the 2 I times by.
Okay.
Alright, let's try another one. Tangent 7 pi over 12. Kind of ashamed to admit it, but I work better in degrees. I shouldn't, but I do. What's 7 pi over 12? What's 180 divided by 12? 15. And 7 15s is 105. So I'm finding the tangent of 105. And I have been told to use the half angle identity. So I'm gonna have to think of this as the tangent of 210 over 2. Isn't that 105? Half of 210? Now, if you were left to your own devices, I don't know a single person in the world that would do this. Everybody else would do like 60 plus 45. But we're told here to use the half angle identity, so that's what we're gonna do. Just another way of doing the same problem. All right, so now we gotta choose which version we want. Doesn't really make any difference. Let's do 1 minus cosine over sine. And what's our theta? If this is how we're doing the problem, what's our theta? 210. So we're gonna have 1 minus cosine 210 over sine 210. By the way, no matter which version you use, the answer will come out the same. This part will look a little different, but the answer will come out the same. All right, 210, what's the cosine of 210? Negative root 3 over 2? So 1 minus negative root 3 over 2 over the sine of 210, which is negative 1/2. All right, so 1 plus root 3 over 2 over negative 1/2. Madeline, I'm right back where I was before. I gotta get rid of these 2's. So I'm gonna times everything by 2. So I have 2 plus root 3 over negative 1, which is negative 2 minus root 3. We didn't do a whole bunch of these kinds of problems, but that looks like the kind of answer we got when we did the tangent of 60 plus 45 or something. That's actually probably easier. It's nobody's go-to, but it's actually easier than using 45 plus 60. I think. All right, anybody have a question about that?
Is it a minus in front of the string, the negative 2?
Yep, because that negative applies to everything in the numerator. Oh, I hear somebody yawning back there. This is fine, no yawning allowed. Here we go, we're gonna find the sine of x over 2. All right, so here we go. Our formula says plus or minus 1 minus cosine over 2. That's our formula right off your sheet. Probably never seen these until today, so just look at the sheet, get it off the sheet. And shoot, they told me the cosine is 3/5, so can I just plug that in? This time I'll have to multiply by 5. So 5 times everything. So what is that? The square root of 1/5, 2/10. Am I going too fast? You giving up here? And the square root of 1/5, if I rationalize, would be root 5/5. So now the only thing left, everybody okay with the arithmetic? So the only thing left now is to decide if we want the positive root or the negative root. We have no idea what this angle is. But we have to figure out if we want the positive or the negative. Sir?
Well, so cosine is x, and then your range is 270 to 360. Wouldn't you want wouldn't you want both? Because it's on the bottom half of the.
Now, you are thinking along the exact right line, sir. Understand that this is whole x. X is in quadrant 4.
Yeah.
Okay? Your question involves half of that. So if the whole x is between 270 and 360, then the half x will be between 135 and 180. Does that make sense to you? So the angle that I am actually using in my problem, the half x, is between 135 and 180, which means it's in quadrant 2. And the sine in quadrant 2 is actually positive. Yeah. So the given information almost always is the whole x. So you gotta figure out where half of that would be. Philip?
Can't you also think since the whole x is in quadrant 4, it would just be in quadrant 2 since
Yeah.
it's the opposite?
Okay. All right. Now we're gonna do an equation using all this, and actually, it's gonna look really familiar to you. Because the only new step is using your identity. So when we look at problem 5A, you have an issue. You have two variables in the problem. You have a sine 2x and you have a sine x. That is not good. So what do you think you're going to do? You cannot solve this equation or any equation that has two variables in it like this. So what could we do? Okay, so we've done that before. Now that isn't gonna fix the problem, but that's something we're probably gonna need to do, get it set equal to 0. You can't have a problem with a 2x and an x in it. So we're gonna take this guy and replace him with what he equals. What does sine 2x equal? 2 sine cosine. This needs to be replaced with what it is. That gets everything in terms of x. This was 2x, not good. Now everything's in terms of x. Doesn't that look like what we practiced the other day? Yeah, what are we gonna do? Factor out of 2 sine, and we're left with cosine minus 1. So sine equals 0, or cosine equals 1. Well, those are all on the unit circle. Where is the sine 0? 0 and pi, perfect. And where is the cosine 1?
0.
You already got it. So 0 and pi are your answers. Yep.
I have a question on number 4, the one we did before.
Yes.
If we had our calculator, or would we have our calculator on a problem like that?
On a problem like number 4?
Yeah.
No. Why would you need a calculator?
Well, I was saying because you could do the second cosine of 3 over 5, and then plug that number for sine over sine second cosine 3 over 5 over 2, and if I did on my calculator, it's the same.
Yeah, well, I hope it's the same thing, right? Now, there is one thing you have to be careful of, Sam, because what you did won't work all the time. Because when you second cosine 3/5, or whatever it is, yeah, 3/5, it gave you an angle in quadrant 1, right? And this angle is supposed to be in quadrant 4. So you would have to manually adjust that if you want to make sure you get the right answer all the time. This one worked out because it turns out it was positive.
Yeah.
The sign was positive, but had it been negative, you wouldn't be right. So here's what you would do. You would second cosine 3/5, and let's say you got 50. I'm making that up total. Let's say you got 50. You would have to figure out what the 50-degree angle is in quadrant 4. The calculator won't give that to you. You have to figure that out. So then you would use 310 and find the sine of half of 310. You see what I'm saying? Yeah. Your calculator will only give you the reference angle. It doesn't put it in the right quadrant for you. You have to do that manually. But yes, indeed, we should get the same answer. It's a good thing when we get the same answer. All right, let's look at the next one. Sine 2x minus tan x equals 0. Okay, you've done enough of these. I hope you're thinking about what we just did, maybe changing this to 2 sine cosine. And what about that?
Sine over
Change that to sine over cosine. Is that okay with everybody? Kind of makes sense. Now what?
You multiply by cosine.
Multiply by cosine. Now let's not panic about that. The rule is you can't divide by a variable, but you can multiply by a variable. So there's nothing wrong with multiplying by cosine. So if we multiply everything by cosine to clear the fraction, we would be left with that. Think so? What do you want to do with that? Factor out a sine. So if I pull out the sine, I'm going to be left with 2 cosine squared minus 1. And if I set those equal to 0, I'm going to have sine equals 0. And then 2 cosine squared equals 1. Cosine squared equals 1/2. And cosine equals plus or minus the square root of 1/2, which is 1 over root 2, or root 2 over 2. Okay. Well, I still have my unit circle up here, so where's the sine 0?
0 pi.
0 and pi. So that one's 0 and pi. Now, where is the cosine? Positive or negative? That would be everywhere, wouldn't it? And 1 over root 2 what kind of a reference angle? Or pi over 4 in radians? 180 divided by 4, pi over 4, 45. So I've got 45-degree angles, pi over 4 angles, in every quadrant. So pi over 4 in quadrant 1. What will it be in quadrant 2? 3 pi over 4, pi minus pi over 4, 3 pi over 4. And then around in quadrant 3, 5 pi over 4. For those of you that aren't quite here yet, it's pi plus 1/4, so 1 and a 4, 5/4. And then all the way to here, 7 pi over 4, because it's 2 pi minus a 4th, or 8/4 minus a 4th. So that problem has 6 answers, those 4 and these 2. Now, we talked about this, that's got a tangent in it. None of these answers are bad though, because the tangent is undefined where? On the y-axis. And none of these angles involve the y-axis, so we're good, we're good. All right. Let's see if we can get these next 2 done, and then I'll stop.
My brain just melts out of there. Yeah. My brain just melts.
All right, so the cosine 2x equals cosine x. Now, cosine 2x is one of the lines, one of the identities that appears in more than one form. The problem is doable regardless of which form you use. But it's going to be easier to use one form than the others. Does anybody have any idea which form would be the easiest for cosine 2x? Sam?
Cosine squared by sine squared.
That's always my go-to, but that isn't going to be the easiest in this problem. It'll work. We'll talk about how it will work. But what might be the easiest to use in this problem? Bronson?
Would be 2 cosine squared x minus 1.
Why, Bronson?
Because it's all cosine.
Yeah. That guy right there is a cosine. So if I use cosine squared minus sine squared, Sam, which is fine, there's nothing wrong with it. I don't want to imply there is. There's nothing wrong with it. The problem is, now I'm going to have to change my sine squared into a cosine squared in order to go on with the problem. So since I have a formula that's already done that for me, I'll just use that version. That saves me a step, basically. All right, what do you want to do with that? You know, we're going to subtract the cosine, get the thing equal to 0. It's a quadratic equation, gang. Isn't that a quadratic equation? So I'm going to get that set equal to 0, and now I will hopefully factor it. Does it factor? If it does, it's going to be 2 cosine and cosine. It have to be 1 and 1. Plus and minus. Does that work?
Yeah.
So cosine equals negative 1/2, and cosine equals 1. Still have my unit circle, so that's good. Where's the cosine 1? Only 0. Now, not pi, guys. You might be tempted to say that, but at pi, the cosine is actually negative 1. Where's the cosine negative 1/2? Well, it's negative over here or over here, right? Cosine.
5 times 6
And this would have to be 1 and 2 and root 3. So this angle is a 60 or pi over 3. Are you following this? There's a lot. So what are the answers? Not pi over 3. It would be 2 pi over 3 or
4 pi over 3.
4 pi over 3. Perfect. Perfect. You're doing great. One more. Then if you want, we can look at everybody's seriousness, so we'll look at that identity. That stumped some of you. All right. Oh no. Oh no, 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 no. What am I gonna do with this, you guys?
Split it into 2x.
Okay. So cosine x plus cosine 2x plus x?
Okay.
Oh, this is not good. Okay. All right, so what do I do with this? Use my formula. And this is like my alpha and my beta, right? Or my x and y or a and b, whatever you're using. So cosine of the first, cosine of the second, minus sine of the first, sine of the second. What? Well, if I'm gonna factor, sir, I have to have the same thing in every term, and I don't. Because I could take a cosine out of here and here, but I can't take a cosine out of here. At least not yet, right now. Do these bother you at all? They should.
Yeah.
We don't want them in there. So you just gotta decide, and I have no idea. Let's make that 2 cosine squared minus 1 again. So this, I just changed it into 2 cosine squared minus 1. I have no idea if that was the best choice or not, but I had to do something. And then this is going to be 2 sine cosine times sine. So this, look at your colored sheet, 2 sine cosine.
Cosine now.
So cosine plus, oh, you want to take a cosine? Can I distribute first and then take a cosine out? I'm afraid it, I mean, do you want to factor cosine out now? We can. Yeah, we can take the cosine out now if you want. Somebody said factor out cosine, so I have one here, here, and here. So if I pull it out, I'll have 1 plus 2 cosine squared minus 1 minus 2 sine squared. These go
Difference is
away.
minus 2 coming
The ones go away.
So I
up. And then
have,
factor out 2.
okay, lots of ideas coming this way. I'm trying to keep track of all of them. So let me see, I've got cosine times 2 cosine squared minus 2 sine squared. And so let's pull a 2 out.
goes to cosine, so that's good.
Should I change one of these? I think I need
Yeah.
to.
It goes down.
I know that factors and stuff, but it's not gonna help, I have to solve this. So let's get it all one thing or the other, so, this is, 1 minus 2, or 1 minus sine squared. So I have 2 cosines, and then 1 minus 2 sine squared. Now I can solve it, I think. Alright, let's make sure everybody's, we did some funky stuff here, which is fine, it all worked out beautifully. But we changed our cosine and sine 2x into their equivalents. And then we noticed that, okay, now they all have a cosine, so we pulled that out. Had some extraneous ones there, had a 2, we pulled that out. Now we got 2 variables here, so we changed it into 1, could have done the other way, could have changed that into 1 minus cosine squared. But now I can set everything equal to 0 and solve it. Yeah. Kind of a mess, but I think we're ready to go now. So cosine 0 where?
0 and 5.
Cosine.
Oh.
Pi over 2 and 3 pi over 2? We just did this one, I think we did it with a cosine, or maybe a tangent, I can't even remember. Where is the, what kind of angle has a sine of 1 over root 2? 45, and it's plus or minus again, so it's every quadrant, so it's gonna be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All of the 45-degree angles, since it's plus or minus. Oh my gosh, craziness.
I did not finish that.